All right. Second lesson. This one's actually a little bit shorter, so you can look forward to that at least. It's on measuring and constructing segments. We've actually decided this year with the distance learning, we're going to skip constructions. Just, you guys at home don't exactly have the tools for that, like a compass, like I can provide in class. And we're just trying to focus on the most important things, anyways, and constructions, and not really all that important as far as getting you guys ready for Algebra 2 or second semester even of this class. So once again, some more vocabulary. We have a postulate and an axiom, or an axiom. That's just a rule that is accepted without proof. Like, you just say something is and people accept it. Such as a straight line can be drawn between any 2 points. It's kind of like, okay, you don't have to prove it, but everyone knows if you draw 2 points, you can draw a straight line, through those 2 points. It could be anywhere on your paper. Wow, I'm not. There we go. Right, so you don't need a proof for that. You just kind of accepted it, I guess. Following that is going to be a coordinate. Coordinate is a set of values that show an exact position. You guys should be familiar with this from Algebra 1. We have x, comma, y as our coordinates on the coordinate plane. It tells you where on the x-axis and where on the y-axis your point is. Distance. I actually really like this example I do in class, which you can't see, unfortunately, but distance is the absolute value of the distance of 2 coordinates. We're going to get into a lot more of that next week. Just understand distance is always positive. Might be a nice little note there. Always positive. For instance, like if I'm here, look at how happy I am. There's my hair. Ooh, I'm better looking than that. There we go. Whatever. If I walk this way 5 feet and then I get over here, right? There I am over here. If I then decide to just walk backwards 5 feet, I'm not going negative 5 feet. It just says I walk another 5 feet. So distance is always measured positive. See, there you go. The distance between 2 points is always positive. Excuse me. Congruent segments. Congruent and equal is a little different. Congruent segments are the same line segments that are equal in length. So congruent usually has to do with something that's visual. So, for instance, here you have 2 line segments. They are congruent. They are the same length. There is no value to them. You don't know how long these are, which is why we don't say equal, but we say congruent. And congruent is represented by segment AB, segment CD, an equal sign with a squiggly on top. And you could be creative with the squiggly, but it's just a squiggly. That means congruent. And the way we show congruency is with tick marks. I call them tick marks. They're called congruence symbol or congruent symbols on this. So if I have, A, B, and CD are both congruent to each other because they both have 2 tick marks. But if I want to say X, Y, and I don't know, E, F, I can use 1 tick mark. In fact, let me use blue to show that these are congruent, and therefore okay, XY is congruent to EF, but XY is not congruent to AB. 2 tick marks, 1 tick mark. Super important thing to take note of there. And we're going to eventually end up with diagrams with tons of things on them. So staying organized like this is going to be super important. Okay, so pause the video and try this example on your own. When you're done, resume and come back to it. Okay, so hopefully you did this. And so first we need to plot the points. We have a coordinate, x, y. So we go to -5 on the x-axis. And then we go up 1 on the y. And our point is there. And we'll label that A. B is -4, 1. So there's my segment AB. And then we'll go to CD. So C is at 3. Negative 5. 1, 2, 3, 4, 5. C. And then D is at 3, negative 2. Okay. Is segment AB congruent to segment CD? Well, that's 1 unit. This is 1, 2, 3. So they are not congruent. So you would say AB, segment AB is not congruent, so congruent sign with a slash through it, to segment CD. You could write it out, I guess, in words as well right now, but we want to eventually transition to symbolic use like we see here, because that's what we're going to be using a lot of going forward in this class. Okay, this theorem, put a big star by it. We are going to use this theorem so much over the course of this year. So much. Second semester, we're going to use it in almost every single chapter. You're going to see segment addition postulate. If 3 points A, B, and C are collinear, so they're on the same line. So they're on the same line. And B is between A and C, as you see here. B is somewhere in the middle. Then AB plus BC equals AC. So I like to color code this. AB is this segment here, plus BC is the next part of the segment. Together makes all of segment AC. Think of it as a railroad track. If you have one piece of rail that you lay down, right? And then you lay in what? That's 5 yards. And then you lay another piece of rail down. I'll just use the same color actually. Add some more rail. Okay, now that's 3 yards. How long is the rail that I just created? Well, it's 8 total. And that's segment addition postulate. Seriously, seriously important. And color coding is really nice to do here. Another way I've color coded this in the past is to do AB and then BC equals AC, the whole thing. And another way is like piece plus piece equals the whole. I'm going to reference that a lot as well. So segment addition postulate. Seriously, seriously important stuff. So then at this point, I'd like you guys again to stop the video. Try the next 2 examples, 1 and 3, and come back and check your work after you finish. So try them on your own first, and then come back and finish watching. Okay, so for example 1, to find the length of ST here, well, we know this. Ooh, you can't see that. RS plus ST plus TU has to be 24. You can do this a couple ways. You can call this X as our unknown because we don't know what this is. And you can set it up as an equation where you have 6 plus X plus 6 has to equal 24. Combine like terms to get X plus 12 is equal to 24. Subtract 12 on both sides to get X is equal to 12. So ST, segment ST is equal to 12 units. Another way you could have done it is just subtract. 24 minus 6 minus 6. Well, 24 minus 6 is 18 minus 6, which is 12. So then you still end up with the same answer. So multiple ways to do it, multiple ways to think about this, whichever one you're most comfortable. If you're a procedural kind of person, it might be helpful to do equations, which we're going to eventually have to do since this will be replaced with like X plus 4. But if you can do something like this in your head, by all means, do that. And then the last example, we're going to skip the goal problem for right now. So this is going to be the last example that we're going to look at. A little bit more challenging. It says QU is 120. I'm going to label this. Ooh. So the whole thing is 120. SU, oh boy. SU is 50. And then RS is equal to ST is equal to TU. So the measure of those are going to be the same. So they're congruent.
Well, I know a good start here. Let me use pink. Is probably QR, actually. I think that might be the best place to start right there, because I can just do 120 minus 50, and that's 70 right here for QR. So I know QR is 70. And it's a matter of figuring out what QS is, which is going to be, let me clear all that out now. QS is going to be that. So I need to figure out what one of those tick marks represents, R, S, and T. So I'm going to look at this part. That's the RU, which is 50. And they're all the same, right? So I can just divide 50 by 3. Oh, I'm sorry. Whoops. SU is 50. That has to be, I want blue again. My mistake. That has to be 50. So then I know, okay, if both of these pieces are the same, and then they both, hey, it looks like a smiley face, eyes, mouth, then they both have to add up. They're both the same number that add up to 50. Well, that would also be the same as 50 divided by 2, which in this case is going to be, 50 divided by 2 is 25. So each of those tick marks is 25. So when I go back to this, let me just clear this out real quick. 25, 25, 25. I know this was 25 because they are all congruent. It says right here, they're all equal. And I know QR is 70. So the whole length of QS is 70 plus 25, which is 95. And that's how segment addition postulate works. So that's it. I think these notes are shorter than yesterday, actually. Nice, only 3 examples, not as much vocabulary, things like that. So with that said, I will see you soon, either tomorrow or later today, to actually do some practice. And I have something further to go on with this that I'm actually going to teach you in class. So well, that's all I got for you today.